In this video, we're going to be looking at some properties of logs. The first property we're going to look at says that log base b of x times y is equal to log base b of x plus log base b of y. Now, in this property, basically what we're saying is that the log of a product is the same as the sum of the log of the numbers. So as you can see here, basically this multiplication is the same thing as adding the two individual logs. So we're going to use this property to work on the next three examples. So on number one, we have log of 2 plus log of 5. What we're going to do is combine these into a single log. So we're going to use this property that says that the addition is the same thing as multiplying these two values right here. So this is now going to become log 2 times 5 is 10. So this now becomes log of 10. The addition is the same thing as multiplying 2 times 5, which is how I got my 10. Let's try that again with number 2. Here we have log base 3 of 4 plus log base 3 of 2. Again, we're going to use the same property. We want to combine these two logs, and this property says that this addition is the same thing as taking these two values here and multiplying them together. So now we have log. Notice we're keeping the same base 3. And if I multiply 4 times 2, I end up with 8. So as a single log, I end up with log base 3 of 8. Number 3, we have log base 5 of 3 plus log base 5 of x. Again, we're using the same property. That property says that addition is the same thing as multiplying these two values. So this is now going to become log. Keep the base 5. And if I multiply the 3 with the x, I end up with a 3x. So this now becomes log base 5 of 3x. The next property we're going to look at is log base b of x divided by y equals log base b of x minus log base b of y. Now this property says that the log of a quotient is the same as the difference of the log of the numbers. So this time the division is the same thing as subtraction, or we can also say that the subtraction is the same thing as division. So now what we're going to do is try a couple of examples here, very similar to the first three we looked at, but this time instead of adding the logs, we're subtracting. And because we're subtracting, rather than multiplying these two values here, this time we're going to divide those values. So now we've got log. We're going to divide 20 by 4, and 20 divided by 4 would give us a 5. So we have log of 5. Let's not forget, guys, that we do have a base here. It's understood to be a 10. If we take a look at the next example, we got log base 3 of 12 minus log base 3 of 3. Once again, we're dealing with subtraction, and the property says that when we're subtracting, we can take these and we can go ahead and take those and divide those. So we got log. We're going to keep the base 3, and we're going to divide 12 by 3. And 12 divided by 3 would give us a 4. So we can combine these and make log base 3 of 4. Number 3, we have log base 5 of x minus log base 5 of 3. Once again, we're subtracting, and the property says that when we subtract, we can take these two values here and divide them. So now what we end up with is log, keep the same base 5, and x divided by 3 would remain x divided by 3. So we end up with log base 5 of x divided by 3. Next property we have says log base b of x to the p power is equal to p times log base b of x. Now this property says that the log of a number raised to a power is the same as a power times the log of the number. So the exponent is going to become multiplication. Or we can also say that that p, that multiplication, becomes a exponent. So we're going to use that property to do numbers 1, 2, and 3 here. So number 1, we have 2 times log of 5. And we're going to rewrite this using this property. And that property says that this 2, that multiplication, now becomes the exponent. So this now becomes log of 5 squared. Of course, I can go ahead and simplify that. If I go ahead and square that 5 squared would be a 25. So I end up with a log of 25. Again, the multiplication became the exponent. Alright, let's try number 2. Same idea. 3 times log base 4 of 2. We're going to take this 3, and that is now going to become the exponent. So now we have log, keep the base 4. We now have 2 to the 3rd power. Now I can go ahead and simplify that. If I go ahead and take that 2 to the 3rd power, 2 to the 3rd power would be a 8. So we now have log base 4 of 8. Number 3, we have 4 times log of base 5 of x. Same thing, that 4 is now going to become an exponent. So now we have log, keep the base 5, and now we have x to the 4th power, which again simply becomes log base 5 of x to the 4th power. The next property we have is log base b of b to the p power is equal to p. Now this property says that if the log, base, and the argument are the same, it's always going to be equal to the power. So notice how the base and the argument are the same. And anytime that's true, our solution or the answer is always the exponent. So if you look at our first example, log base 3 of 3 squared. Notice how the base and the argument are the same. And anytime this occurs, the answer is our exponent, which in this case that exponent is 2. Number 2, log base 4 of 4 to the 5th power. Once again, notice how the base and the argument are the same, and anytime this is true, the answer is your exponent. In this case, that exponent is 5. Number 3, we have log of 10 to the 3rd power. Now, although you don't see a base there, remember it's understood to be a base of 10. Therefore, the base and the argument are the same, and because they are the same, the answer is our exponent, and that exponent is 3.